Hello, my name is METİN Arıdaşır. This is 423rd part of explanation of my theory. Here, my new formula for, I hope you see. Yes. Relation between spectral line wavelength and atom-bound electron wavelength formula. Here, K is effective wave number of free electron motion form. Arıdaşır's atomic theory principles. My atomic theory principles. 1. First, second, third, each ionization energy in an atom corresponds a specific initial wavelength of unexcited, undisturbed in its ground state cycling proton-bound electron. This is its wavelength. For X atom and electron. Even if an electron is an angular ring-shaped spherical three-dimensional cyclical repetitive motion form, we assume proton-bound electron is at rest in its ground state, not relocating. 2. Free electron motion forms consecutive ways make proton-bound electrons expand at the rate of their squared wave number, k square. Like this. When the effective waves partially or wholly vanish, this time proton-bound electron contracts proportional to the square of the wave number. This time wave number decreases through 1, and I show decreased wave number as like this. Downside arrow with K, okay. Like this. Downside K represents a smaller K number, wave number. Upside K, greater wave number. For instance, between first wave and 8th wave, between second wave and say third wave. Okay, now second wave, downside K, third wave, upside wave, and squared. Yes. While contracting, a proton-bound electron push out a single light wave pulse. 3. A single wave pulse has a corresponding wavelength that is nothing but a specific spectral line wavelength here. Lambda, single wave pulse, K, between K, upside, K, downside. Okay. A single wave pulse has a corresponding wavelength that is nothing but a specific spectral line wavelength lambda single wave pulse. 4. There is direct relationship between a spectral line wavelength and proton-bound electron specific wavelength at its ground state. This is my formula, predictive formula. In my next video, I will apply this like what? Like this. Left side my computation, right side NIST data, for instance. Okay. For helium, different electrons. One of electron wavelength is 22.7841. Other one 50.44109. Smaller electron, greater electron. When they disturb by effective wave numbers of electron motion forms expands at specific rates, contract, then when they vanish, effective waves vanish, contract with specific wave number. Then while contracting, they push out a specific wavelength. This is my formula. New formula for predicting spectral lines. Yes, so if I know ionization energy value of an electron, I can predict all spectral lines wavelength values under the effects of waves that I know their wave numbers. For instance, for helium, first ionization energy is what? First ionization energy is 39.38 10⁻⁹ joules. Second greatest ionization energy is 54.4. Then corresponding wavelength for this 22.78 nanometer, etc. Okay. Have a good evening. See you later. METİN, Arıdaşır.